In this video, we're going to be looking at tangent lines. And one of the things about a tangent line is it's a straight line that never enters the interior of a circle, but as it crosses and contacts the circle, it makes a right angle. And so that's when I say tangent line, that's what I mean. So notice this problem right here. It wants us to find the value of x. And looking at this initially might look confusing because you got this circle here and you have this line going across. But do notice that this line right here that's labeled 11.2, if I were to continue going, it would touch the circle at this point and then just continue. But it never enters the circle. And notice that we have another line here that goes from the center of the circle over to its edge. And we actually call that a radius. And we're going to talk a little bit more about that in the next video because you're going to need to refresh your memory on radius and diameter for some of these problems. Now what I would tell you is, looking at this, I do know that this line is tangent. And if I were to get my protractor and I wanted to confirm, I could use this cross right here, right? These two lines on my protractor, they make a 90-degree angle. And I can set it right on top of there. And you can see if I line up the dot right in the center of that opening on my protractor, you'll see that the little black lines line up perfectly with this line that crosses left to right and with the line that's vertical that goes up and down right here. Right? So what we say is they create a 90-degree angle. In other words, this line, this top line, if I were to draw it all the way across, right, it is perpendicular to this line represented by the variable x of the triangle. So because we know, we can tell by looking at it, that it does make a right angle, a 90-degree angle, and it contacts the outside of the circle but never enters and goes across, it's a tangent line for certain. And because of that, we know this is a right angle, and therefore we can solve for this missing value because we can now apply the Pythagorean theorem, which will solve for the missing side of a triangle as long as it's a right triangle. So I'm going to refresh your memory real quick. When we talk about the Pythagorean theorem, we're talking about the formula where we say a squared plus b squared is equal to c squared, with c being the hypotenuse and a and b both being a leg of a right triangle. In other words, I'm going to go ahead and go over here. Here's my right angle sign. So I'm going to say that this side over here is leg A. And this side over here, our tangent line, is going to be leg B. And this side over here is the hypotenuse. So I'm just going to write that underneath it. I'm going to do it with the different colors, so because it's going to cross the circle. That way it stands out. The hypotenuse, which is my C value. So now that we know this, right, we have A, B, and C, we can go ahead and we can use the Pythagorean theorem in order to solve it. So I'm going to go ahead and substitute my values for each variable. So in this case right here, A is represented by the variable x. So instead of A, I'm just going to write on here x squared. And we are putting a square on it because A is squared, right? So if we replace a variable with a variable, we're replacing A with the letter x, which is what they gave us in the problem. I do got to make sure I square it. And then I'm going to add that to the value for b. Now with b, we're not putting a variable in its place because b has a value. Our value for b is 11.2. So I'm going to go ahead and put 11.2 squared. And I'm going to set that equal to the hypotenuse. And the hypotenuse is this 14 right here. That's the longest side of the triangle. It's also opposite the right angle. And it's 14. So in place of C, I'm going to put 14, and I'm going to square it as well, because C is represented by 14, but C has to be squared. Now, from this point, we're going to go ahead and use inverse operations to isolate x and get it by itself. Now, you could go ahead and put 11.2 squared in your calculator if you wanted to and get a decimal answer, but it's probably going to have a decimal strand. And because of that, I recommend that you just leave it exactly like it is and subtract that whole term and move it over to the side. And I'll show you what I mean if it sounds confusing what I just said. For instance, here we're adding 11.2 squared to x squared. So the opposite, our inverse operation, would be to subtract 11.2 squared. Now, if I subtract it on the left side of the equation, it cancels. I must also subtract it from the right side of the equation so that it stays balanced. So 11.2 squared. Now we do have a number over here. We're going to be subtracting it from 14 squared. And so I'm going to put that in my calculator. So I'm going to grab my calculator real quick. And from here, I'm going to go ahead and put in 14 squared. and then minus, because I'm subtracting, 11.2 squared. And I'm going to go ahead and hit enter. And notice that gives me 70.56. So I'm going to write that down real quick. So I have 70.56. I'm going to bring down my equal sign. And the only thing left on this left side of the equation now is x squared. Now we do run into an issue here. We don't want to know what x squared is, because that would represent the area behind the side that labeled x. We want to know the linear value. We want to know how long is that side of the triangle. So we have to unsquare this. And to unsquare it, we have to take the square root of it, because that cancels out that power of 2. It cancels out the square, which means I also must take the square root of the right side, because whatever we do to one side, we have to do to the other. So this on the left just becomes a single x, a linear value that we're going to have. And now I'm going to take the square root of 70.56. So the square root of 70.56, and it gives me 8.4. So in this problem, if you get one like this, right, that's all you do is use the Pythagorean theorem, and notice the answer for this problem is x is equal to 8.4. So the length of this side of the triangle is 8.4.